Hello and welcome back to Doz's Television Workshop. Today we're going to be doing the third bit of Ian's Leaky Leak kit. This is a Leak Stereo 30 Plus and it needs a renovation. Let's get into it. Okay, first thing we'd better do is just check the plug. It does say it's fitted with a 3-amp fuse. Make a pleasant change. Actually looks quite decent. And for those of you who are not aware, in the UK we have fuses in our plugs, and that is a 3-amp fuse coloured red. Terminals are all tight. The live terminal is shorter, so in the event of the cord grip failing, that pulls out first, thus rendering anything else safe. Brilliant. Oh, that makes a pleasant change to see. Okay, so this is going to want a recap. It is going to be a number of years old. Those capacitors in there are going to be well past their best. Ooh. So off with the covers. These are sort of fiberboard covers. You see, by this stage of manufacture, Leak got round to using Phillips screws. Look, much better. Okay, they're only held in at the 2 screws there, and then these sort of cardboard, sort of like clips, like car body panel trim clip sort of arrangements. There we go. And you can see the underside of it's silvered to, I don't know, some attempt at screening it. Very nice construction inside. I tell you what, this one is very, very clean. Good. And we do the same with the underside. This is the second one of these I've done for Ian. He bought another one. Not as tidy as this example, I must say. But we brought that one up to scratch. Yeah, it's all in really nice condition. Good. Okay, I think what we need to do here is actually work out what capacitors we need, because we should recap everything, and then go from there. Yeah. Let's get a shopping list. Alright, so wrote myself out a shopping list, placed an order, and our packages arrived. We've also got some capacitors we've always sort of keep in stock. Yeah, just looking around things. A good few of these capacitors have got blisters, certainly these blue ones here and here. Not so much these silver ones. The last one of these I did was in very poor order. Right, what I'm going to do is I'm going to do these sub panels first. I'm just going to mark the left hand ones with a bit of Sharpie. I'm going to take them all out. It does make getting at the rest of it quite a bit easier as well. So these 2 boards here are the power amp driver boards, and these 2 pots you can see down in there. So let's do a bit of zoom in, and so there we go. Oh, yeah, that's better. So yeah, the 2 pots you can see there to adjust the bias of the output stage. Output stage on this amplifier is 4 2N3055s. That's the difference between a stereo 30 and a stereo 30 plus. The stereo 30 had a germanium output stage. Stereo 30 plus is all silicon. Right, so those, like I said, power amp control boards, and these 2 are the preamp boards. So let's get those out and get them recapped first. So this is, I love the way this works. This is spring loaded, this bar. So you just pick it up and turn it, and there it is. And you can then just simply unslot the PCBs from the edge connectors. We'll give these edge connectors a bit of a clean when we're in there as well. So that's interesting. Boards are completely different colours, look. Now what? Not so the driver boards, they're the same. Anyway, we'll put the chassis just down out of the way while we work on the preamp boards and the driver boards. Okay. So this is the boring bit where all we've got to do is change all these capacitors. And people say to me, oh, why do you change them rather than testing them? Look, these things are 50 years old now. Chances of them being any good are slim. Those of you that are observant, by the way, you'll now notice I got a third camera. So we've got a big Clive cam at the top there, one to my left and one to my right. The one to my right is the one I usually use as a presenter cam. It's nowhere near as good as the other two, so but it does give us another angle that might be useful. And I've also moved this camera, the one on my left, forward a bit. Somebody suggested I ought to do that. One of my colleagues at work said it would make it easier to see. Right, let's get on with this. There we have it. That's the first preamplifier board. So there's a before and after shot, look. So more modern components replaced there. Right, let's press on with this one. There we go. That's the other input. It's the other input board complete. Input preamp board. So some of these values, by the way, differ slightly from old to new values. Just go for the next best thing. A lot of these capacitors were 32 microfarads. Well, you can't really get 32 anymore, but 33s are easily available. So that's the value we fit now, and very rarely will you run into any problems substituting those values. Certainly in electrolytics, other capacitors in tuning networks, etc. Very important to get the right values, but not here. Right, let's carry on with the driver board. So there we have it. For quickly recapped boards. Brilliant. One other thing we want to do, let's get just a tiniest little squib of service oil and give those edge connectors a quick clean. just to remove those marks. Just a slight bit of abrasive on there. Yeah, they're cleaning up beautifully. Lovely. There we go. Wonderful. Right, okay. We can put those to one side now and bring our main chassis back in. Let's go in there for future reference. Right, we need to bring our main chassis back in, like I've just said. Put it away. I'll put the boards to one side. There we are. Right. And the main chassis back in, because we've got these horrible things to do now. Oops. There we go. Which are the CAN capacitors. So, basically, what we need to do is to preserve the look of it. We're going to undo these clamps, take these capacitors out, get the tops off, pull the guts out, put a modern component inside the capacitor, and then fit this cap over the top, which sort of helps maintain its look, and it gives us somewhere to mount the new component as well. I've seen other people make a PCB to go in here and wire it up, which is actually quite a neat solution. But I think this is neater. These caps, by the way, you can find if you've got a 3D printer or make with a 3D printer, you can make these very easily. The link for these is on the website. I should put it down below. So yeah, and you can download that from Thingiverse. The link to Thingiverse directly. Thingiverse has all manner of problems some days. Sometimes it works, sometimes it doesn't. So we can't trust it. I'll link it that way, and you'll be able to find it. Good, right. So first things first is to slacken this clamp off. Now it's got a screw that you probably can't get at. We'll have a little go at it. Just switch that off. We probably can't get at the screw. Can you see that on the camera? Not really, because I'm right over the edge. You can see it on these cameras, right? So I can just sort of get in through the bottom and on there, but I can't get any purchase on it. Certainly can't get at it from the top, so it's not happening. So we need to find a spanner that we can get in there, which is my little spanner. And what's the betting? It's gone into hiding. No. Is that the one? I think it is. Oh, it is. Wonderful. Right, but we can't get on the nut because of the orientation of it. Oh, right. We may have to resort to pliers just to slacken it off and get it moving. Yep. And the screw's turning as well. Oh, it's not going to be our day, is it? Can I stop the screw from turning? You can take the whole clip out from underneath. It's not the end of the world. Do you know what? I think we're going to be doing that, aren't we? Because that's just not happening. Right. So under here we have got a diagonal Phillips screws. If I would turn it upside down, I can show you. So the cans are here, here and here. As you can see, the screws are diagonal. So right, let's take one of those out. There we are. Now, one thing we can do here is just snip these tags off. I'm going to recycle those in a moment, so we can just snip them off. Oh, come on. Oh, thank you. Right, now it comes. Should be, yep, 500 microfarads. We don't have 500 microfarads, but we do have 47. 470, sorry. And I knew we had them somewhere. There they are, already in stock. Wonderful. I was starting to panic then that RS had left them out of my order. They were never in the order. Good. Okay, let's just undo this. Slacken the clamp off. To pull the capacitor out. Right, now we've got to get its guts out, and this is the interesting part. There are many ways to do this. Some people like to cut them around the top, which you can do. I like to just gouge it out. And I have a tool for the very purpose. And yeah, some of you may recognise this as a corkscrew. And you'd be exactly right. So we can just get in there with it. Generally, try not to stab yourself. Once it hooks in, it'll just rip it apart and we can just pull it out. The other way to do it is to just drive a screw in. A large screw. Just an ordinary wood screw or something of that ilk. Yeah, we're in. We are in. Ooh. One thing I should have done before I started all of this was put a pair of gloves on. Because, oh, my corkscrew appears to have disassembled itself. Oh, dear. Incidentally, never ever disassemble an oil-filled capacitor. That oil is horribly carcinogenic. Got it. And yeah, it won't do you any good at all. So best to avoid those. Anything that ends in OL, visconol, things like that. Avoid those like the plague. Don't restuff them. If they're faulty, just replace them. And take them to your council yard where they'll dispose of them for you. They're full of polychlorinated biphenyls, which can be very nasty. It's one of those chemicals that never leaves the body and is stored in the various organs, which won't do you any good. Right, well, this is slowly coming apart. They either put up a fight or they fall into your lap. And this one is obviously going to put up a fight. Right, we've just got the actual capacitor itself to deal with now. And I mean, you can see in there, you hold that up, you can sort of see around the edge, it's sort of waxy. So another good way to get these is to get them warm. So yeah, let's do that a little bit, shall we? Where's my rototherm? Here it is. So we just this is not an open flame, by the way, so I wouldn't recommend doing it with especially as we've got a plastic jacket on this one. But just a bit of warmth on there should soften that wax a little bit. So we can try and extract the insides. Incidentally, there's no unpleasant odour or anything with these. It's just a matter of getting it to come out nicely. Oh yes, go on. So it's come unstuck from its wax, and it's just jamming in the top. I think we're going to need to sort of manually keep working away at it, get it to yield a bit. Oh, that's promising. I don't know whether you've ever had one of these explode. Something we all used to do at college, but it is just a big electrolyte soaked sort of bit of paper with some tin foil, sort of electrodes all the way around as a spiral to give it a huge surface area so it gets good capacitance. Gosh, oh, it's nearly there. It's nearly there. It's nearly there. Whew. Ooh. Ooh. Quite easily see the construction here, can't you? That's our spiral of conductive material and our electrolytic soaked cloth. Actually still quite moist, this one as well, but it had started to vent, so there we are. At last, the can is empty. I'm just looking for a date code on here. Nothing conclusive. Right, so we'll just finish getting the last dregs out of that. There's a bit of sealing wax in the bottom. That can stay there. And we can get our cap. Our 470 microfarad capacitor. Right, here's a good point. A good tip at this point is to mark your leads up, because once we solder the tag back on, we won't be able to see which one we're in. Obviously, the modern component is much smaller, so it just fits inside there. Snap the cap back on. Locate my red Sharpie for positive. So that's snapped on. Yeah. Red Sharpie for positive. Just colour that lead. There we go. This can's got a little bit deformed when we got it apart. That's it. That's it. The cap is now on. Excellent. Right, let's clear this mess up and then put that back in the chassis and get on with the next one. And just hopefully it comes apart a little easier than that one did. I think it may be time to pension off my bottle opener. What a shame. Right, let's clear this mess up. Right, let's got everything back into some semblance of order. Right, we need to replace this clip, so we can place that back in there, tighten that back up. Oh, let's take my gloves off. Oh. Like everybody, I really dislike working in gloves, I think, but it's, you know, it's a sensible precaution to take. Right, now we're going to make this somehow look like these have got terminals on. Let's pop those two screws back in just to hold our clip back in place. Yeah, one's in. Oh, missed. If there's any date codes on the transistors, actually, I shall have to have a look. Whilst we're here, RCA transistors are not even 2N3055s. They are 16006s, which is an equivalent, and it's obviously whatever they could get, but made by RCA, and sadly no dates on them. Right, so now what I intend to do is, with my pliers, I'm going to fold this top lead over and stop it all descending back into the can for a moment, like that. And I'm going to solder that tag onto there. So soldering irons on, nice big juicy tip. So I can just work very quickly. Solder that one on there, beautiful. There we go. I don't think that looks too bad. Now, just the others. Ooh, there we go. I do hope these yield somewhat easier than that one didn't. Or at least the guts come out easier. Oh, that's interesting. And a little annoying. Never mind. Keep that over there for now. And we shall repair that when we come back to it in a minute. That's better. Many hours have passed. All the 1-inch diameter cans have now been restuffed. So all that we've got left to deal with in the capacitor department is this mains smoothing capacitor. So I'm going to take the clamp out from underneath as we've done previously. Let me just snip the tags off again as we did last time. Okay, come on, come on. Put so much solder on some of these tags. I'm mainly cutting through solder rather than tag. Trouble is with these single-stranded wires as well, you don't want to sort of work them back and forward too many times because they do tend to break. Come on. Ah. Oh, that's not helping, is that tag is just spinning. So I get in with these cutters on it. It's a little sharper maybe. Da-da-da. Cool. Don't really come like you used to. That's just spinning on its rivet, that tag. Got it. Right, let's unscrew the capacitor clamp. Now, last time I did this, there was a strange capacitor in there, and it had been obviously failed sometime in its life, and it had been replaced with a thinner capacitor. And to get it into the jig, they sort of packed it in some sort of toilet cardboard tube of a toilet roll or something. So yeah, not ideal. So I made a plastic spacer up, but this time I've managed to find a capacitor that's a bit closer to the original. So let's just have a look, see what we've got. All right, so that's the cap, and the one I bought to replace it is this fella here. So I'm just going to slacken this clamp off. This, I'm sort of smelling a rat here. This fitting is very, very much different on the end of that than all the others. It's got a Phillips screw, and yeah, oh look, we've seen a bit of abuse here as well, so I don't think this part is original. And this nut's a nylock, and yeah, it didn't have a nylock on it originally. Where's my spanner? Oh, of course it's a different size nut. Oh, it's the other end of my spanner. How lovely. So, right. I've just got a feeling that this, I'm fairly sure this has been replaced before. Probably to deal with some level of hum. That's the fault condition when this capacitor fails. Right, that's coming loose now, so God, it's still tight. What I'm hoping is, obviously modern parts are smaller, physically smaller. So what I'm hoping is That's a Plessy can. Plessy capacitors. Mini can electrolytic. 1973. I don't think that was new when it was fitted. Right. So this is what I've got to replace it. Obviously it's a very much shorter affair. 4,700. This was 50 volts. This is 63. But as you can see, it's a similar sort of diameter. But, well, let's see what we can do. If not, I will have to set about printing an adapter again. This bracket has been twixt, bent as well, so let's straighten it. That'll help. Where are the needle nose pliers? Underneath the chassis. That's better. I still think we're going to need to 3D print some form of adapter for that. Yeah, that's that all the way done up, and it's not going to fit. Right, so we're going to need to draw up an adapter. And, ooh, oh, everything descends from the shelf above, including my digital calipers. Right, so we need this to be 30 millimeters, and we want this to be we say 37 millimeters, then we've got enough to play with. Right, let's get on the computer and design and 3D print a little spacer to sit in there. Lovely. Right, so we've designed a bit of a spacer in Fusion. So we shall chuck it into our slicer. There we go. That looks all right to me. I shall slice it. I shall export the G-code. Cap spacer in PLA will be absolutely fine. There we go. So let's save that out. We just where is it? Cap spacer. Got to be that one. There it is. Yep. Right. Okay. So we'll just open a web browser. Connect to. Didn't mean to do that. Connect to Octoprint. There we go. We'll just connect the printer. Lovely. And we shall drop the cap spacer into there. And we shall set the time-lapse video, because we haven't done one of those in ages. Time-lapse mode on Z change. There we go. Save changes. Lovely. And I happen to know the printer's in good alignment, so I shall just hit the print button, and we're away. We'll come back when that's done. There we go. The 3D printer's been busy making us a little adapter. So I'm hoping if I've got my measurements right, that should just snugly push into there. Oh, beautiful. So that's good. And then that should fit in the clip. Oh, thing of beauty. Right, now let's bring the amplifier in shot a bit, shall we? Just tidy up this. Done with the calipers, let's put those away. That's the packet for the capacitor. We shall play with that later. Right, tidy it away. That's our sad capacitor. I've changed the nut and bolt on here. Don't like nylocks, they're a pain in the backside, so we've got just a plain M3 nut and bolt there. Okay, we'll set screw and bolt, I should say. Right, so we need to make this look. So that is riveted in, that ground connection. So we need to make it look like it's through there. Okay, it wants to come round a few degrees, doesn't it? There we go. Is it sort of in line with the clip, I wonder? Yeah, it is. That's super. Ooh. So we just do that up. Little spanner, I think. I don't think there's much danger of it falling out, to be honest, but there we go. That's perfectly tight enough. Good, that looks super. So it goes there, or does it there? Yeah. Right, let's get some screws in the other side. Where is it? There it is. Ah, butterfingers. I don't think this is the original clip. I reckon the original clip fitted in that hole. I reckon that hole's been drilled out and somebody fitted a different capacitor, perhaps. Used a different clip as well. It might have been done from the factory. They may have run out of the appropriate parts. Difficult to say because we've not been able to date the unit. There we go, let's have a look at that. Yeah, that looks good. So what we've got to do now is remake our connections there. We'll need a warm soldering iron for that. Nice fat prongs soldered up. And one. There's the other. Lovely. Good, that looks okay. Right, and it's time to put the boards back in. we've got our two driver boards. I believe I marked the right hand board, so right can go in there, left can go in there. And the preamplifier boards, that's the right one. And there's the left one. Okay, pop the spring-loaded retaining bracket into position. And we can just shuffle the boards about until they click into their respective grooves. Have I got those the right way around? I haven't, have I? Not in the slightest. Ah, now I know what the problem is. That is that way up. Ah, left, right, right, left. Good. I'm pointing that way. Brilliant. Okay. Now, the next thing to do is clean these pots here with a little dab of magic Servisol. Let me get that. Okay. Okay, it's my tweaking tool. Oh no! It's snapped off! Oh, I'm gutted. That's my posh ceramic one as well. Oh dear. I'll use this old-fashioned plastic one instead. It'll be just as good. So just a tiny squib on there, and I'm just going to move them back and forward just a little bit. Return them roughly to their position, because we're going to be setting the bias up anyway. Just to clean those contacts off. Right, so let's look at how to set up the bias. Okay, we've got our service manual loaded. Instructions to service engineers, blah, 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 blah. Current adjustments IQL and IQR. The quiescent no drive current in the output stages of the Stereo 30 Plus amplifier has been set at the factory at 30 milliamps, and it should not be necessary to reset this current unless a driver transistor T8 or T9 on the output transistor has been replaced. To readjust quiescent current, well, we're going to do that. I know we haven't replaced any of those parts, but it's a good practice. To readjust a quiescent current to red flexible current links, see layout diagram, connect the collectors to the 48 volt. These wire links should be disconnected and ammeter inserted. Adjust the, right, okay. Quiescent current by resetting P5L, P5R. Those are the two pots we've just cleaned. So where is the layout diagram? Let me just zoom out a bit. Oh, there we go. Ooh, gone too far. There we are. Those are our two IQR and IQL current links. Now, I seem to remember, do not, under any circumstances, leave these disconnected. I think it damages the driver transistors. So, oh, it's something else to notice on the service manual while we've got it open. Look how they've drawn the transistors. Isn't that lovely? Yeah, so that's how they used to draw a transistor. Well, Leak used to draw a transistor. Before it was sort of standardized, this sort of thing was quite common. So here we've got our base look there, collector and emitter. Yeah, very interesting. So let's lift those links. They're shown on the circuit diagram here. Look, one there and, only one channel shown. So there's only one. Right. Let's do that. So here is our red current links. I'm actually going to disconnect those from the collectors. So we can insert an ammeter in there and set it to 30 milliamps. Okay. So there's one. And there is the other link. So we can connect a meter in there and measure the current. Right. Excellent. We've got the soundtrack of a chainsaw in the background. That's wonderful. Okay, right. So, multimeter. We've lifted the links, as you've seen. So now we need to swap the multimeter over to current. So we need to move this. This is a Fluke 77 I've had for many years. So we've got common and 300 milliamps. And we need to put the negative pole on the collector. So I shall do that. I've got a little croc clip on the end of there. This side is the HT. I'll come back to that in a minute, which is 48 volts. I have got another multimeter, this time a Fluke 87. Again, we're going to move that across to milliamps there. And again, I've got a croc clip placed on there, wrong colour. I must buy some more of these. They're very useful, little 2mm croc clips. So we need to put this connection to our 48 volts. I'm just going to use a clip lead for that. Ooh. Let's pick the right colour this time. Let's have a red one. Okay. So actually that's really dog-eared one. I bought some lovely new ones recently. There we go. Don't need to have a dog-eared one, let's have a decent one. So that will then connect to one of these. So we've got 2 meters in series measuring the current into the collectors. So we need to set this round to milliamps. This one the same. Amps DC. Yep. Milliamps. Now this meter always defaults to AC. Drives me mad. There we go. So that's DC, DC, DC. Fabulous. It's ready to switch on. So I've got my main supply connected. Pilot lamp is lit, so that's good news. And we're getting precisely no current flowing at all. That is a worry. Okay, what have we done wrong? These are connected. Milliamps, common, milliamps, 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 DC, milliamps, DC, amps, DC, milliamps. That should be giving us an indication. We get a microamps, see if there's anything going on. AC, DC. Right, we have no current flowing. That's okay. Let's find out why not. I suspect we are missing the HT rail. Okay, right, let's disconnect all of this. Oh, lead, warning. That's the one good thing this unit does do. It detects when you've got a lead inserted incorrectly. So let's push this one to one side for one moment. I'm just going to reconnect those current links. Because I do remember once in my life damaging the driver transistors. There could be a false memory, I could have dreamt it. But it certainly won't do us any harm just to put these back down. Right. Okay. Let us, I'll use this meter, but it's set back up again now. Ah! I can see what's happened. Did we not solder that properly? Oh dear. Let me just That's it, we're isolated from the supply now. It's on an isolation transformer anyway. Try not to work on stuff that's live, if I can possibly avoid it. Right, let's just do a quick preliminary check then. We've now got some voltage on across that capacitor. That's going to be the filter capacitor. So let's check things out. Power is going on. We've got our indicator lamp lit, so that's something. And I've got 44 volts, which would make perfect sense. Okay, let's see if we can measure that current again. Disconnect from the supply. If we just, we'll use the other meter and we'll just try one for now. And if that then reads, we can do the other side perhaps. So that's our current link. There we go. This is our switch back on. Still nothing. There's no crackling or anything going on either. Okay. So we know we've got 48 volts on the supply itself. So let's just see whether that's getting to the collector, which it should be. Still 44 volts on there, despite the fact we've switched off. Okay, so on this lead, we should have 44 volts. We've got nothing. Nothing at all. Okay. Why have we got nothing? Have we got an open circuit fuse? So, well, how are the fuses labelled on this unit? Disconnected from the mains again. So, we have DC fuse and an AC fuse. Okay, so let's just have a look at this DC fuse. This is the bit where we take it out and it's wrapped in tin foil. And my heart sinks. No, it's not. Should have checked this ages ago, really. It could be we've just put, you know, a brand new capacitor in there. Could be it's just seen it off. Ah, no, because we've got voltage across the capacitor. Therefore, the fuse must be after the event. So, what have we got? Place your bets. And it's open circuit, isn't it? Yeah. Okay, jolly good. Let's hope it hasn't failed for a reason. Just failed through old age. So I'm going to leave these fuses on the back, these spares, and we're going to fit a new 1.6 amp from my box of fuses, which is over here. A mapping kit. God bless it, from years gone by. So 1.6. 1.6. 20 millimeters, lovely. Pop those back on the shelf. I'm just going to confirm the fuses can sort of sneak in between those compartments. I'm just going to confirm it's 1.6 amps before we go any further. And it is the wrong end. 1.6, how lovely. Right, okay. We may get a little pop here as this goes down. No, no, good. Oh yes, there we did get a little pop from the speakers. And why that's happened is we've just completed that circuit to the output stage. And of course that mains capacitor, our main smoothing capacitor that we've changed, that's had voltage on it. So yeah, that's to be expected. Let's hope it just didn't draw so much current that it's opened the fuse again, because then we have a problem. Right, I'm just going to clip the lead back on here to measure the quiescent current and see if we get... we got a crackle in that speaker this time as well. Good, that is good news. Okay, switch on the power. We have current flowing. That is good. So we've currently got amps DC 13. I don't think so. I think that must be milliamps. And got a little noise from the speakers at high volume levels. Good. That is good. Only on one channel. It's because I'm only measuring one channel. Right, okay. So we're a little shy on our 30 milliamps of quiescent current. Amps. It's not amps, it's 300 milliamps. That's okay. I just couldn't understand that for a second. It's not often you use the amp setting, really. Right, which pot is it going to be? Don't place your bets. It's that one. So we need 30 milliamps showing on here. 33, touch high. 26, touch low. It's going to be a fussy thing to set. 35. So what I might just do is try and knock the wiper along a bit. Might just be a little easier. $36. No. 30.7, close enough for government work. Right. Let me do the other side. I may as well. Just, yeah. So you need to go and measure the voltage on our capacitor, see if we've discharged adequately. 2018, 16, 14. Yeah, he's on the way down. Good. So I'm just going to disconnect that. Resolder our link. Yep. Take this one off. Okay. And reinsert the Fluke 77. So that's our supply feed. This is our collector. And we'll set this one to 30 milliamps. Power's going on. Okay, again it's a little bit low. $25, $34, too many. $27, not enough. $33, it's very scratchy, this pot. This is when a multi-turn pot is a joy in these. Oh, look at that, 30.2. Close enough for government work. Okay, so that is our bias set. When you finish doing bias on your meter, always return that lead to volts, because there's obviously there's a current shunt in here, and it's very, very low impedance or resistance. So if you then think you've got something set to volts and go and try and measure a voltage for it, you short it out, blowing the fuse in the meter, possibly damaging the meter. I have blown multimeters from here into the middle of next week by making that mistake when I was a younger man. Don't do it. Just takes 2 minutes to move that probe back over. Okay, so let's solder our current link back in there. Lovely. And let's get a signal source and do some more testing. Okay, we've got a signal source set up from my dear old MP3 player. That's going into tuner 2 at the moment. So Something's definitely not right. Would have a lot of gain up. And it comes right and then goes off. That doesn't sound at all as it should be. Okay. Right. I'm just going to... Yeah, so the gain switch is working because we can utterly overload that side. Oh, hang on. Okay, so we have got a signal on one channel, and it is the right channel. We have got a very, very low signal on the other side. Okay, that's good. Bass and treble controls are really very smooth, so that's good. All the controls are very scratch free. Treble filter's working. This, by the way, is a false knob. It's the headphones knob, but it's not a knob at all. It just fits in the hole to cover it up. I think it's a lovely touch. So, why have we got low gain on one channel? So, I think the first thing to do is to pull the gain cards out, the input channel cards, and swap them over and see if the fault moves. Right, power's going off. Turn that round. Swap these over and see if the fault moves with the card or not. Oof, right, one in. Two in. Start my music back up. Power going back on. There we go. Okay, so the fault is in fact following the card. That's good. We've instantly identified possibly where our problem is. Okay, let's just confirm which card it is. Because I don't trust leak and their left-rightness after last week's debacle. So this is the working card, that's the faulty card. Jolly good. And that actually makes sense, I think. Good. Right, so power off. Let's pull this preamp card out and have a little look about what's going on in there. That one, of course, lives now in there. So it's quite possible we've made a mistake in soldering when we changed the capacitors. So it's magnifying glasses on and have a close look to see if there's any dry joints or cold solder joints, not that maybe we've made or maybe we've missed when we were reworking the card. I must say it all looks very nice, except for that there. Have we got a lifted bit of print? These boards are very old and very fragile now, and probably weren't the best quality in the world when they were new. So it's quite easy to damage a track just by working on it. Put that onto beat range. No, that's okay. All right. Any shorts anywhere? A bit of a blob over maybe. No, it all looks very, very good. About that one there. That's it, yeah, that's as it should be. Of course, fault finding live on this board is going to be a little bit difficult because we can't get at it when it's in the unit. So we're going to have to do quite a bit of dry sort of testing to see where the fault lies. I don't like that track there, but it's not connected to anything. What about this one here? No, it's good. That one is good. That one, good. Okay, I suspect back in the day, if you were a leak dealer, you could probably get an extender card that slotted in to give you some access to fault find on the relevant board. So let's just check the top side of what we've done. Have we got them all in the right way around? That would be catastrophic. They're all absolutely fine. Let's see which bit, because we are dealing with a line level input. So maybe we need to look at the schematic and go back from there and see where that is. Let's just do that and see if we can come up with some hypotheses as to why that channel's not working. Right, one schematic blown up as far as I dare. So the preamp section is sort of in this section here of the board. You can see these numbers here, 2, 19, 17, 15, 16. These are the pin numbers on the edge connector. Pin 1 being right towards the control panel. Pin 3, pin 18. So we've got one channel that's low in gain. So all the electrolytic capacitors are new. Oh, by the way, you'll notice the odd way the transistors are drawn. This has sort of happened before the transistor symbol was internationally agreed as that sort of K with the arrow on the leg that we all know so much today. So you've got obviously base, collector, and emitter on there. And I suppose, was this done to make engineers that were more comfortable with valves? I think it looks a bit like a valve. Don't know. Anyway, there we are. A little bit of history. So we've got one channel that's low in gain. So we know the signal coming in at pin 1 is okay, because if we swap this card out with the other channel, the volt swaps with the card. So it's everything after here. And I think what I need to do is we need to check the presence of the supply voltage, 31-ish volts, on pin 3, and also pin 18, 35 volts. These three transistors here just form a gain stage. This final one then drives this tone stack, if you like, there. Again, these pots you can see are off board, obviously because they're attached to the front panel, pin 8, 9, 11, etc. This is then passed to two transistors there, which is our final gain. Here's our treble filter. Well, we know that's working. Balance pot could be suspect. We've had that before in a stereo 30, so that's possible. Tape monitor switch and out. I think what we better do is the record plug there. So if we scope up at the record plug, then we've bypassed the balance pot for a start, and the tape monitor switch as well. So if we come out of there, just put a signal in and put our oscilloscope on there, we can then see how if the fault is in this switching arrangement. I don't think it is, again, because most of this is off board, but we could have a fault in the routing or something. The other point of interest here is this section here. So this is part of the negative feedback circuit. Now, negative feedback is used to reduce the distortion in the amplifier, in this preamp, and also it's used to, when set to pick up 1 and pick up 2 here, it adds this network in, which is sort of RIAA compensation, but in the feedback loop. Quite neat. So, yeah, interesting little piece of circuitry there. Just the ordinary sections just have a couple of resistors and this bit of compensation here, just to set the gain of this stage up. Although well, some of the switches have a high-low gain switch anyway. So there we go. Let's put a scope on our record socket and have a look, see what's happening there. Okay, so that's interesting. That's input right on both, input left on both, which is what you'd expect. And that's stereo. I beginning to suspect this switch again? No, there is no output on one side. Right, I had to stop recording because we ran out of memory card on some of the cameras. In the interim period, whilst I was downloading all the files, which takes forever, I have removed both these cards and was dry testing lots of things, even where I could get on here making comparison checks live in circuit with the oscilloscope voltages. And do you know what? I could not see a difference between the two cards, except for this lighter colour card appeared to be working. Channel was, you know, nice and loud. This darker card appeared not to be working as it was quieter. Oh dear. Just like Ian's last very slope amplifier, the card that was loudest was actually the one that was at fault. And let's have a quick look at the diagram and I'll show you for why. So there was a break in the print in this circuit here. So C17 that we'd replaced, the print had got damaged ever so slightly just here. And what this loop does, it's a negative feedback loop. So it turns the gain down on the circuit and improves its distortion. But also it enables us to switch in this network here, which is the RIAA compensation network done in the negative feedback loop. Very clever, and why not? So these switch settings up here, i.e. tuner 1, tuner 2 and replay, are all flat, and then these two down here, pickup 1, pickup 2, go via this network and then back into there. But with this capacitor open circuit, there was no negative feedback, so we were running open loop gain on these 3 transistors and had far too much gain. So that was the problem. There was nothing wrong with the card I thought there was. So yeah, that took a little bit of finding really, and a silly mistake to make. So now it all sounds in stereo and is very good indeed. As you can see, the 2 traces there are very good. The amplifier is also, you might not be able to hear it on the microphone, but it's got plenty of bass, and the output stage is coupled by 1000 mic capacitors, so there is all the speaker current is being drawn through those capacitors, which can limit the bass response, but it's not lacking here. It's great. So that's it, another one repaired. I hope it'll give Ian many years of service. All that remains to do now is to check the other inputs I'll do off camera, and to yeah, just box it back up and he can have it back. So there we go. Thanks for watching, and yeah, click like, subscribe, ring the bell, all the other stuff, and I'll see you really soon here at Doz's Television Workshop. Thanks now. Stars in the lab again. Sorry, Fran. Love you really.